Unit 7. Teaching Chemical Process Skills. Unit Introduction. Process skills are a means for learning, and are essential to the conduct of science. Perhaps the best way to teach process skills is to let students carry out scientific investigations, and then to point out the process skills they used in the course of the investigations. There are 6 steps that teaching chemical process shall follow: observation, communicating, measuring, comparing, contrasting, and organization. The unit contains inventory of materials for practical activity, and proper inventory methods. Storage of resources is also vital for chemicals, to avoid cross-contamination. Most laboratories are conducted by students and teachers in our school system. But the skills obtained, and understanding the process is minimal. Understanding the purpose of chemistry laboratory and designing is very important before conducting the experiments. The last section of the unit explains how to conduct experiments using locally available materials, so students can understand the full chemical process. The unit explores the resources required in a chemical laboratory and handling mechanism of the chemicals, and other resources. Understanding chemistry concepts using locally available materials is both cost-effective and helps students fully understand the importance of science in our daily life. Learning outcomes. Upon completion of the unit, the trainee will be able to categorize chemistry teaching/learning resources, manage independently chemical laboratories, coordinate the chemistry practical activities with the theoretical classes, design different high school chemistry models and laboratory activities, demonstrate different chemistry experiments. Section 7.1. Use of chemistry teaching/learning resources in chemistry practical activities. Activity 7.1. Give names of important resources for learning chemistry at high school level. How do you handle the apparatus and chemicals in the lab? If chemicals are not available in the lab, how do you use the local environment as teaching resource? The following resources are essential for practical activities in chemistry. Proper laboratory manual, which is revised and updated to satisfy the curriculum change, and the availability of resources. Technical assistants which are well trained and willing to assist students. Practical laboratory room with supply lines, water, gas, or electric, and proper ventilation. Separate room for storage of chemicals and equipment. A single room for storage of chemicals is common practice in many laboratories, and alphabetical order of chemicals is common practice. But some chemicals are not compatible and should not be stored separately. Based on compatibility, at least 5 rooms are required, and special storage could be essential for chemicals which are not stable at room temperature. Such facility is very difficult to find in Ethiopian condition in high schools. Chemical inventory system is very vital for safe use of chemical in industries and chemistry laboratories. The practice do not exist in our system, and many chemicals are dumped after storing for many years. You may visit any chemical store and ask for a list of chemicals and related information, date of acquisition, storage condition, expiry date, etc. A possible solution for current misuse and mismanagement of chemicals in Ethiopia is having a centralized chemical storage for a given locality. Schools, both government or private, through membership or affiliation, can obtain the required chemicals at any time they require. It is also advisable that such centers will provide dilute solution and some distilled water rather than concentrated solutions, since most schools have no facility to prepare solution or to prepare distilled water. In text question 7.1, what are the 5 compatibility groups for chemicals in stores? Most Ethiopian schools lack proper laboratory facilities or have no laboratory rooms. Storage and handling of chemicals as well as apparatus and chemistry laboratory is very vital. For example, you are handling volumetric apparatus such as burette. The tip of a burette could be clogged with dust or etching of the inner surfaces of the glass by basic chemicals. Therefore, handling of burette after each experiment needs washing and putting upside down to prevent etching as well as clogging of the tips. The other common problem which is common in our laboratory system is laboratory handling stock solution. Stock solutions are concentrated solutions and must be kept in the store. A portion of the stock solution can be used by using reagent bottles. This method reduces the risk of contamination of the stock solution and possible loss of the stock solution. One can mention as many issues as possible on handling, storage, transport, and use of chemicals and equipment. It is the responsibility of the teacher and the technical assistant to manage the resource as well as teach students the proper handling mechanism of chemicals and equipment. In the laboratory for future career, teachers should use the material in textbooks selectively and adapt them to the different needs and abilities of the students, rather than working through them from cover to cover. They are advised to exercise their professional judgment in selecting tasks and exercises from the textbooks and make use of other ready-made resources or produce their own to develop a wide range of learning activities for their students. Modern technologies such as Internet can also assist teaching learning process in both theoretical as well as practical class. Industries around your area could be also used for practical activity centers, and students will observe both chemical process and application of chemistry for development. Traditional activities such as distillation, leather making, dyeing, etc. could be best laboratories for students. Laboratory instruction is a cornerstone of most science programs because it allows students to be actively involved in their learning. Many educators value the laboratory's instructional potential, but laboratory has also been the focus of considerable criticism concerning the lack of student learning in laboratory. Therefore, there has been increased interest in alternative laboratory instruction styles, such as inquiry-based or problem-based laboratory experiments. Activity 7.2. Design an experiment to produce clue from locally available materials. You can also collect different plant leaves or bark to prepare tannin, which can be used as dye or cosmetic purposes. Check that all products obtained can be used for a number of activities at home or in the laboratory. Section 7.2. Purpose of chemistry laboratory. Activity 7.3. Practical activities can be conducted using ready-made materials. However, in Ethiopian condition, you may not find the necessary materials. But one can design an experiment using locally available materials. Think of one chapter, electrical conductivity of solutions or electrolysis of brine solution. Design an activity with little or no cost. Traditional laboratory courses are based on written instructions that students follow to complete laboratory activities. Students in this study perceive that the written documents and structured experiments held authority over the science that they were allowed to perform. The reason little has changed in practical classes in Ethiopia is probably that university teachers concentrate on the experiments to be performed by students and on the time available, rather than on the educationally best way to achieve their teaching aims, although all the evidence that they need to improve practical teaching is easily available. The aim of practical work in chemistry is to achieve skills related to learning chemistry, practical skills such as handling equipment, measuring, and observing carefully, etc. Scientific skills such as seeing science at work, devising experiments, etc. And general skills such as teamwork, reporting, presenting, etc. Laboratory work in chemistry can be seen as discovery method or problem-solving approach, and integrated laboratory instruction. The study of inquiry discovery method has also reported that the student's performance in the chemistry laboratory can be enhanced by student-centered procedures. It gives each student an opportunity to discover for him/herself much of what is ordinarily given in the lecture. The student is confronted with problems and is expected to devise an explanation based on his/her experimental results. However, implementation of this unstructured approach to laboratory instruction seems rather difficult at secondary school due to extensive resource it requires, the large demand on faculty members, the great demand of highly dedicated and competent teaching assistants. The chemical facts and principles are very often first presented in the lecture, and then exemplified in the laboratory. Chemistry should be taught in laboratory in order to emphasize the character of the discipline as an experimental science. Therefore, giving students the opportunities of working in laboratory is giving them the opportunities to act as scientists or learn how scientists work. The following are some of the basic importance of laboratory work. Laboratory work enables students to 1. Understand the physical properties of chemicals. Most students do not have the opportunity to see and understand the color, odor, texture, and some other physical properties of chemicals, unless they get the opportunity to work in laboratory. 2. Differentiate between toxic and non-toxic, hazardous and non-hazardous chemicals, and know how to handle them. Almost all students do not have the courage of touching, smelling, and testing of all chemicals regardless of their toxicity. This is because of absence of exposure towards chemicals. 3. Observe the physical and chemical changes that are taking place during chemical reactions. This is crucial since writing chemical reactions on the blackboard is quite different from practically undergoing the reaction, as there are unexplainable observations on the blackboard that can be revealed during laboratory work. 4. Acquaint with the different laboratory techniques in chemistry. There are a lot of techniques that a student learning chemistry at secondary school should know. For example, boiling point determination, distillation, drying solid compounds, filtration, evaporation, etc. All these techniques could be attained in the laboratory. 5. Differentiate between different glassware, adapters, clamps, and other apparatus, and their use. This will help them to use the proper apparatus for handling chemicals and performing reactions. 6. Be able to prepare a setup to perform an experiment. 7. Become familiar with measurement devices. It is very important for a chemistry student to know how to handle, how to manipulate, and how to use different instruments in the laboratory. 8. come across with observation of events that cannot be explained theoretically. 9. Develop learning by doing and scientific attitude or problem-solving skill. 10. Satisfy students' curiosity greatly. Section 7.3. Designing a model and practical activities from high school chemistry topics. Activity 7.4. In Ethiopian context, laboratory materials and laboratory rooms may not be available. So the possible option you may have is to design an experiment based on locally available and cheap materials. You can try the following experiments from locally available materials. 1. Electrolysis reaction materials require dry cell battery, NaCl solution, aluminum foil, hard paper for glass cover and glass. 2. Hardness of materials. Materials required fingernail, piece of broken glass, stainless steel knife, quartz. Using the above materials, one can test the hardness of many solid. Teaching chemistry without experimental work in the laboratory is synonymous with swimming in the mud with very little water. Similarly, a chemistry teacher that is dealing with the theoretical part cannot impart properly the clear picture of the course to his students. Therefore, laboratories are not only supportive of the theoretical part chemistry, but also an important part of chemistry course. However, most laboratories in our secondary school system lack proper experimental support. Very few students can correlate the theoretical concepts with reality. If you teach about burning of CaCO3 and write the following chemical reaction, very few students can understand that they can prepare cal by the above method at home using charcoal as heat source. CaCO3 plus heat cal plus CO2. To design a model or practical activity, students must understand the materials available around their locality. With the help of chemistry teachers, they can design the experiment and test it at school level. For example, you may be planning to teach redox reaction of metals. One can design an activity using simple materials such as soil, iron nail, some salt, water, and students can easily understand the extent of corrosion in each system. Corrosion effect is stronger in a system that contains salt substances, and can be explained using the nature of chlorine as powerful oxidizing agent. Computer-aided models can be more effective to teach some experiments. For instance, electrolysis reaction is very hard to visualize for a beginner in the field. However, computer models can show the movement of electrons during electrolysis and show different parts, where only the effect can be seen on actual experiment. To teach the chemical bonding, ball and stick model can be used to study bonding of molecules. You can use clay to make balls and toothstick to connect the balls. Activity 7.5. To teach corrosion of metals, one can observe different places and compare the level of corrosion. Consider the following site. Metal piece on the field. Metal door in the toilet lower part. Metal piece in water, etc. Make a group of 3 and study each metal and report the level of corrosion. Design also a computer model that shows the corrosion process of metals. Assessment mechanism. 1. Most chemicals are not compatible to other chemicals and laboratory resources. Suggest possible methods of arranging chemicals and resources in a chemical store which is safe. Reduce cross-contamination. Individual written report. 2. Discuss and find the ways that the laboratory experiments facilitate the classroom theory teaching and learning, and the other way around. by considering practical example. Group discussion.